Hello, welcome to the lecture series of computer networks. I am Harsh Khattar, working as assistant professor in Department of Computer Science, Kite Group of Institutions, Ghaziabad. In last class, we discussed about the transmission signals. In this lecture, we will continue with the signal transmission and what type of signals we have, and then we talk how we are transferring our data with the help of encoding schemes in physical layer. Very first thing is, what is the difference between data and signal? Generally, we have data and we want to send it to my friend or from sender side to receiver side in the form of signals. Here on the screen you can see that we have data of two types. One is the analog data, another one is the digital data. Right now in this current era, most of the data which we have is in the form of 0 and 1s, means digital data. In digital data, our data is in the form of binary bits, and the sequence of binary bit stream, we have digital data. This data is transferred from sender side to the receiver side. How we can transfer our data? When we convert our data in the form of signals, as we have analog data and digital data. In a same manner, we have two types of signals, analog signal and digital signal. Analog signal is one when we are sending our data in the form of sinusoidal waves, which is continuous in manner. In digital data, we are taking 0 and 1s bits, and then we are trying to convert in the form of analog signal with the help of a process where we are using sampling and quantization. When we are transferring our digital data in the form of digital signals, then we have the another encoding schemes. My focus in today's lecture is on digital to digital conversion, means digital data is converted towards the digital signal, so that we are transferring it from sender side to the receiver side. If you want to study more on the digital to analog conversion or analog to digital signal conversion, then you can study about the analog digital converter. To understand the signal transmission, we need to study about some basic terminologies which are related towards the transmission, like what is the frequency, what is wavelength, and what is bandwidth. Generally, we have seen, we can say easily that yes, my bandwidth is low, the frequency of the signal is this, the amplitude and the wavelength of the signal is this. So, what it means? It is clearly mentioned on the slides. You can see when we talk about the oscillations, the number of oscillations per unit time, generally we are taking it as per second, and the frequency unit is hertz. So, we have seen in the processors in the system that yes, the speed of the processor, the frequency is basically 1 gigahertz, 2 gigahertz, 1 megahertz. So, what it means? It is basically the frequency, the oscillations per second. So, this is our frequency. Based on the frequency, we are calculating the network oscillations. Similarly, we have wavelength. Wavelength says what is the propagation speed of the data and what is the frequency. When we consider these two factors, we can easily compute the wavelength. Wavelength is basically the distance which we are measuring. So, based on these two parameters, we can say yes, this is our signal, this is our data which we are trying to send. Next important factor is bandwidth. Bandwidth is basically the range of the frequencies within a given band. So, we have a limited bandwidth and we are saying the bandwidth of this channel is this, and we are transferring a data and the data transfer rate is slow. So, basically there is a direct relation between the transmission of signal and the bandwidth. We will discuss on these three factors in the coming lectures wherever we are applying it in the form of numerical. Now, with these previous three factors, we have some sort of distortions, attenuations and noises. Means somehow when we are transferring our signal from one end to another, some sort of irrelevant data added in our signal. So, how we can say it is a attenuation or distortion or noise, how we can recognize it. So, there are three simple examples to understand this concept. Number one, if I am sending my signal and this signal losing its property, means something is subtracted from this, then this is the example of attenuation. So, we are saying yes, I am sending my signal and the signal is received with some property loss, means loss of energy or resistance, we can say it is attenuation. Okay. When we talk about the signal is received, nothing is lost, but some of the properties rechange, means we can say some of the properties reshaped. The shape of the signal, the amplitude of the signal is not as per what we have sent. In this case, we can say yes, some sort of distortion is there in our signal. So, this is all about the distortion property. Next is something is added in our signal, like here we can say something is subtracted. In noise, something is added. Yes, the signal is there, with signal we have some sort of improperties which are added in my signal. So, this is basically the noise. So, we have some noise removal methods, because something is added and now we want to remove it, and for this the solution is amplification. If there is some sort of loss, we want to get the exact signal. So, in this case we need to amplify it. So, these are few terminologies related to the signal transmission. Now, as I said, in today's lecture our focus will be on digital to digital conversion, means digital data is converted to the digital signal. How it is possible to convert the digital data into digital signal, and what we are trying to do with the digital signal. So, the answer is very simple. Suppose I want to send some data to my friend. So, this is data in the form of hello, hi messages, and then this message is converted to the bit stream in the form of binary digits, and this binary set of digits, binary bit stream, is basically known as data. Now, this data is going to the receiver end. How it will go? When we convert it to the digital signal. How we can convert data to the digital signal? With the help of some algorithms. These are the algorithms. Okay. So, here it is clearly mentioned, when we have some data like this, this is my data stream, what I want to send to my friend. This is my encoding method which converts this digital data to the digital signal. Okay. So, this is very important concept to understand, and in university exam you will find at least one question, numeric question as well as the conceptual question from this topic. So, this is very important to understand. As mentioned here, we have three different types of encoding. What is the meaning of encoding? Means we have something and we want to change the nomenclature, the structure, and we want to convert it into a different manner. So, this is encoding. We are coding something. So, I am converting data into the signal. One by one we are discussing all three types of encoding in detail. Very first one is known as unipolar encoding. What is unipolar encoding? When I have a stream of data, say my stream of data is in the form of 1 and 0, because it is a binary number system. In binary number system, how many combinations we have? Only 2, 0 and 1. So, if I am representing my signal in the form of voltage, then I can represent 1 as high voltage and 0 as 0 voltage, not negative voltage. If I am talking about a signal, we can represent this as a baseline. This is my baseline, the x axis, and above x-axis I am representing 1 and on x-axis I am representing 0, not below. So, this is the example of unipolar. In unipolar, we are only focusing on the one direction, means above the x-axis, as it is mentioned here that the voltage levels are represented as 1 and 0. 1 represents high voltage, which is positive, and 0 represents 0 voltage, which is baseline. Baseline you can treat it as x-axis. In some of the schemes you will find in the question that negative part is also taken. So, this is another category of algorithm. This type of encoding is basically known as the unipolar encoding, and it uses only one polarity level, which is on the positive side. Okay? In unipolar encoding, you can see the polarity is assigned to only one state, which is above 1. We have two combinations, 0 is baseline and 1 is the upward direction, the positive edge, high voltage. If your data stream is this and you want to represent this data stream, means digital data to the digital signal, how you can represent it? 0, as I said, this is the baseline. So, it will start like this, and then 1. 1 means high voltage. High voltage means we will represent it as this. So, this is the example where you can see it is 0 represents baseline, 1 represents the high voltage. Once 1 is over, it will come back to the baseline. Then 0 represents baseline, 0 represents baseline, then 1 means high voltage, like this. So, here how you can represent where to move up and where to move down, you can see these dotted lines, these vertical lines represent this is the area of 1 bit. So, if I am representing this particular area for 0, so in this case you will see the baseline working, this one. Okay? So, always remember, whenever you have seen a question of unipolar, do one thing, wherever you are finding 0, it means there is no movement and you can move towards the baseline only, no positive, no negative. And in case of 1, represent it as a positive. So, it is a quite easy way to understand and draw this 0-1 combination. So, this is first one, which is unipolar. Another example or the second category is basically the polar encoding. Polar encoding is a bit different, where we have 3 different types. One is basically the non-return to 0, means we are not returning to the 0, 0 means baseline. Another one is basically the return to 0. Whenever we are going upward or downward, we are returning towards the baseline, this is return 0, and this is the biphase. In university exam, the most important part out of these encoding schemes, we have these two, Manchester and differential Manchester. Every year there is one numerical on Manchester and differential Manchester encoding scheme. An input stream will be given to you, and you need to draw this signal based on the Manchester and differential Manchester. Basically, initially these schemes were given by the G.E. Thomas, but later on based on the IEEE standards, these schemes are modified. So, I will talk in detail in the coming slides. Currently, it is important to understand in polar encoding scheme, we have the two voltage level, one is the positive and another one is the negative. Means we are not focusing on the baseline, but we are returning to the baseline. As mentioned here, non-return to 0, this is return to 0 and this is the biphase. In NRZ, we have two combinations, one is NRZL and NRZI. I is for the inwards. Let us talk in detail about first category. Yes, this is the first category under the polar encoding scheme. what polar encoding scheme says that we have two levels, one is the positive one and another one is the negative one. How we can represent the positive and negative edge when the data stream is given in such manner? This is your input data. In the question, this binary data stream is given to you and it is mentioned that you have to find the NRZ scheme, polar encoding scheme for this particular thing. So, first thing is what is NRZ? NRZ is basically the non-return zero scheme which represents the signal either on positive edge or negative side. So, on positive edge we are moving. So, this is the upwards direction is the positive one and the lower direction is the negative one. When we talk about the L and I version, there is a slight change. What is the change? You can see it is clearly mentioned here, whenever we are moving towards the level of the signal depends on the type of the bit which we have. So, we have two types of bits, 0 or 1. Whenever we have 0 orientation, we will behave like this. Okay? In some of the books, the orientation is changed. As I said, the schemes are as per the scientist name and then as per the standards it is modified. So, here I am taking the reference of Forozen book, okay, data communication. Forozen is a well known book. So, this is the diagram or example from the particular book. Here if 0 is encountered, then we are moving towards the positive direction. If 1 is encountered, we are moving towards the negative direction. So, basically in these type of schemes, if you want to create your own scheme under the polar category, you can define it in such a manner between the sender and receiver. Suppose I am saying I am sending a signal where the peak, the positive edge represents as 0. So, whenever the receiver receives the message, it will predict and decode it in a same manner. Yes, 0 means high value and 1 means negative or low value, low voltage. Similarly, I can repeat it with the different nomenclature. For example, I am representing this positive or high voltage as 1 and low voltage as 0. So, it is up to me what I am defining to send the signal from sender side to the receiver side, and once the signal is received at receiver side, then receiver end will decode it in a same manner. Okay. So, here this is an example of Forozen book and we can see 0 is represented as the positive or high voltage and 1 is represented as a negative voltage. So, wherever you are finding these zeros, you will find this high. Okay. 1 represents the negative, this one, and 0 high, like this. So, this is basically the linear manner. So, we can say NRZL. What is the inverse scheme? In the inverse scheme, wherever we are finding this 1, currently what we are trying to do, we are seeing the number of bits and what is the bit type, 0 positive, 1 negative. Now, what we are trying to do in the inversion, we are focusing on the transitions. Transitions means we are focusing on if I am getting the value 0. So, in this case, this is the value. In case of 1, I am changing the transition. So, wherever 1 is encountered, we are changing the transitions. It is clearly mentioned here that in this inversion scheme, the voltage level that represents 1 means we are doing transition. Transition means the change of phase. So, here this is 0. In 0, initially we are moving like this. If 1 is encountered, so we are in the positive mood, then we are taking it as a negative part. Okay. Now, 0 is there. When 0 is there, no transition, means we are on the same pace. So, it is not required to move on the positive side. No. There is a difference between this L version and inversion method. In L version, we are defining 0 means positive, 1 means negative, okay, or vice versa. Here, we are saying we are moving towards the transition. Whenever 1 is encountered, we are doing the inversion of signal. So, here 0 is there, common, then 1 we will invert it, then 0 same, 0 same, then one is encountered, inversion, then one is encountered, inversion, like this. So here you can see these type of inversions are there, again one inversion, then 0, same, like this. So this is the inversion scheme. Okay. Next, return 0. What is the meaning of return 0? Return 0 says whatever we are moving, we are returning to the baseline. So here I am defining some values. If 0 is encountered, we are moving from the negative to the baseline. If 1 is there, positive towards the baseline. Similarly 0, negative towards the baseline and positive towards the baseline. So this is what we have in the polar encoding in return to 0. So this is return to 0 method. Okay. Next, this is a very important scheme which is known as the polar encoding scheme under the biphase. As I said, these are the important ones for the university exam, Manchester and differential Manchester encoding. What is the meaning of Manchester encoding? Manchester encoding says that we are encountering 0 and 1s, based on values we are changing the transition. Like if we are talking about Manchester first, then 0 means positive to negative transition and 1 means negative to positive transition. So these are the forms, means things are fixed. For example, this is my input data stream. If 0 is there, so positive to negative, this one, this is a complete part. Okay, wherever you will find 0, this is the positive to negative, like this. Okay, and whenever you have 1, then negative to positive. So this is as per the IEEE standard. If we are talking about the G. Thomas method, then the nomenclature is reverse. You will find in some books that it is from negative to positive for the 0. So here I am taking the example of 4 In differential, again we are focusing on the transitions. If I am fetching the value that 0 is there, then we are putting the transition. If 1 is encountered, then no transition. No transition means no change of phase. So focus on this. If 0 is there, we are moving suppose in this manner. We are assuming that the signal is in continuation. So don't bother about that we are moving from upward to downward or downward to upward. It's up to the continuation of signal. Might be you can start from this manner, then this is the original signal. At this point, we are using our 0 and 1. So here I am saying if it is 0, 0 means transition, means we need to change the phase. So 0, if it is in upward direction, we are moving towards the down, this one. Then it is 1. In case of 1, no change in transition. So this line will move forward like this. Then 0, okay, go to this, change transition. 0, again change transition. 0, change transition. 0, change transition. Suppose after this 1, so it will continue like this. This is 1. Okay. So this is about the encoding schemes. So this is very important. I would suggest that at least 2 questions you can try by your own with the help of books. References are given here. You can use the book Forozen, or you can also refer the Java T-point reference here. Third one is the bipolar encoding scheme. In bipolar, we have 3 things. One is the orientation of positive, then negative and baseline. In this case, we can say the beauty of the bipolar scheme is when we have the ones, we are changing the transition. Like you can see here, when we have these 3 voltage, positive, negative and 0, in bipolar scheme, initially we have this binary 0, binary 1 represented as the alternate positive and negative voltage. So whenever 1 is encountered, take an example, I am talking about AMI scheme, which is the alternate mark inversion. Suppose my signal is 0, 1, 0, 0, 1. In this case, we are saying 0, 1, 0, 0. Now 1 is encountered, we will invert the value. So here on 1, we are inverting the transition. So this is how bipolar encoding scheme works. This is all about the schemes which we are using for digital data to digital signal conversion. So if I talk about what we have learned in today's lecture, we are talking about the signals, signal transmission, how we are transmitting the digital data in the form of digital signal. What are the relevant questions from this? Why digital signals are preferable when we are sending the data? Discuss different types of encoding schemes. So, we have seen 3 examples in this: unipolar, polar and bipolar. Under these we have different examples, and main one is the Manchester and differential Manchester encoding. Now, you can also take an example of numerical. You can see previous year papers and you will find the example of Manchesters. Now, there is a self assessment question. If you want to transmit data, which encoding scheme you will prefer? Okay. So, this is what you can analyze by your own. So, this is all about the today's class. Thank you. In next class, we will talk about the ISDN, and we will also take a quick recap of unit number 1 and what are the important questions for university exam from unit 1.